This is my Physics of Rope Sports lab report. In this lab we analyzed a video of a spring and mass system moving in a simple harmonic motion, and the purpose of the lab was to analyze this motion. The results of my analysis indicated that the system consisting of the Earth, spring, and mass satisfied the energy principle. Relevant models to this assignment include both the spring and the pendulum. The spring model was relevant due to the oscillation in the y direction from spring force, and the pendulum model applied due to the movement in the x direction, seemingly elliptical. When analyzing the tracker video, I set the origin at the fixed attachment point and used the given length of the spring at equilibrium of 0.7 meters to make the unit stick. I then created a point mass of 0.402 kilograms and tracked the movement of the mass throughout the time of the video. Both the x and y component graphs portrayed the oscillation motion. This data was then exported to a CSV file for later use. I modeled this motion in VPython. I inserted all the necessary values, such as the mass of the ball, the relaxed length of the spring calculated from the video, and the spring constant, which was also calculated from the video. I then uncommented all the provided code so as to compare the model with my data. When I run the model, the orange ball represents the modeled motion, and the blue ball is the data from the CSV file. The model is then plotted against the original file, where the red line is the model and the green line is the data. This is the graph of the expeditions. As you can see, they start very similar in size, but then as the time frame continues, they begin to deviate. So, what does it mean? Well, for one thing, the period of oscillation is different for both x positions and y positions. This can be seen here, where when I run the module for the y position on the same time interval as the x position, the code presents an error right here. This is because the period for the y component is actually around 0.2 seconds slower. This is due to the fact that to calculate the period of oscillation, the x component is a pendulum, so you use the formula 2 pi square root of t over g, whereas for the period of the y component, which is a spring motion, you use the formula 2 pi square root a over k. So two separate equations result in a slightly different period. This system does satisfy the energy principle, as the work done by the surrounding is just air resistance. No other work is done on the system. This is also the reason for the deviation of the graphs, as the model is essentially the ideal motion, whereas the data from the CSV file is real-life motion. So what happens if we change the origin? Well, here we have the original graph, plotting the total force, kinetic, and potential energies. Here is the same code, but I have changed the gravitational energy set origin to 0. When I run the code, the differences between the graphs is clear. The yellow graph is the kinetic energy, and the red graph is the potential. So it can be observed that as a result of the change in origin, the total kinetic energy increased, while the potential energy decreased. Thank you. That is my lab.